Hello, and welcome to our AP Chemistry review of topic 5.4, elementary reactions. When we're talking about the kinetics of a reaction, or the rate at which a reaction takes place, we're going to learn that there's what's called a reaction mechanism. In other words, how the reaction takes place. Does it occur in one step, or does it occur in multiple steps? And so when we're talking about these steps in a chemical reaction, we call these elementary reactions. And to best understand an elementary reaction, we're going to look at an energy reaction profile or reaction profile for an elementary step. So I'm going to draw an energy diagram. So we have energy on the y-axis and we have reaction progress on the x-axis. And in an elementary reaction, we only have one transition state and we have no intermediates. In other words, we have an activation energy creating a transition state, and then we have a product, and that's all there is to an elementary reaction. There's not multiple transition states and there are no intermediates. What I mean by that is it can be exemplified by another type of energy diagram for a multi-step reaction with multiple elementary steps. So let's look at what that looks like. If I look at the reaction progress versus energy for a multi-step reaction, you start with your reactants. There's a transition state, so an activation energy, that goes down and creates what's called an intermediate. Then those intermediates react, another activation energy, that requires more energy, and then they produce a product. This particular energy diagram has two elementary steps. One creating a transition, an intermediate, and then those intermediates producing our final products. So this would be a two-step reaction with two elementary steps. An elementary step simply has one transition state and no intermediates. So you can have what's called a unimolecular elementary reaction. In this type of reaction, you just have one reactant and it's rearranging into some product or products. Unimolecular, uni meaning one, there's only one substance that's reacting. You can have a bimolecular elementary reaction. And of course, I spelled molecular wrong up here. Molecular. Bimolecular, bi meaning two, where you have two reactants. And those two reactants can be different or they can be the same. So for instance, you could have substance A reacting with substance B to produce a product of some sort, or you could have the same substance reacting with itself to produce some new product. Both of those are good examples of bimolecular elementary reactions. And again, it's called bimolecular because you have only two reactants. The last one's called a trimolecular, and these are very rare because in order for a trimolecular elementary reaction to occur, you have to have three particles simultaneously collide into each other, and that is very difficult to occur. So in a trimolecular reaction, you could have three different particles colliding into each other to produce some type of product. You could have two of the same reacting with a second in order to produce a product. Or you could have all the same substance colliding into itself and producing some final product. That's a trimolecular elementary step. And again, in all of these, you have one transition state. The reactant or reactants are directly becoming products. There's no intermediate step in the process. Unimolecular and bimolecular are the most common type of elementary steps or elementary reactions. Trimolecular, very rare because it is rare for three particles to collide into each other simultaneously. And there have been no observed tetramolecular elementary reactions where four particles have to collide into each other to produce a product. Another important part about elementary reactions is that the coefficients of the reactants are the exponents or orders in the rate law for a particular elementary reaction. In the past, we've talked about how the exponents are not the coefficients in the chemical reaction, and that's in a multi-step reaction. But when it comes to an elementary reaction, the orders are indeed the coefficients from the elementary reaction. So for instance, for this unimolecular reaction, the rate law would be written rate equals the rate constant times the concentration of substance A, which is the only reactant, raised to the coefficient power. So if the coefficient is 1 here, then the order would be 1. All right, so for the bimolecular reaction, the rate would be the K times the concentration of A times the concentration of B, both raised to the first power because the coefficient is 1. For the next example that I gave you for a bimolecular reaction, the rate would be equal to K times the concentration of A, and since there are two A's reacting here, then the coefficient would be 2, and so the order would be 2. Again, the way you would write this reaction more traditionally would be 2A produces C. So the coefficient is 2, so the order is 2. For the trimolecular reaction, for this first one that I gave you, with A reacting with B reacting with C, the reaction would be the rate constant times the concentration of A times the concentration of B times the concentration of C, first order for each one of those because the coefficient is 1. For the second reaction that I've given here, that's a trimolecular reaction. Again, if this is an elementary reaction, the orders correspond to the coefficients. So the rate would be K times the concentration of A raised to the second power, because there are two of them, times the concentration of B raised to the first power, because there's only one of B reacting. And then for the third example that I gave you, the rate is equal to K times the concentration of A raised to the third power. And notice that this has an order of 3, which we said is very rare. Usually there's 0 order, first order, or second order. And again, that's because it would be very rare for 3 atoms or molecules of substance A to collide into one another simultaneously. Trimolecular reactions are very rare. So this third order for substance A would be an unusual event. So that is how rate law correlates to elementary reactions, and how elementary reactions coefficients correlate to the rate law. Good luck in your studies, and if you have any questions, of course, let me know. Bye-bye.